Welcome back. So we're gonna do something that's a little tangential, but still related to function combination, and talk about the difference quotient. So you'll see why this pops up in a minute. But the difference quotient actually has a lot of application in calculus. So in calculus, you'll see the limit definition of derivative, which we give here, and well, you look at that and you're like, oh man, calculus is going to be tough. It is actually not too bad once you learn the notation. But here, we don't necessarily know how to know what this f tick of x, and then there's this lim thing. We don't know what that is, but the expression in red here, f of x plus h minus f of x all over h, we know how to do that. That's function combination, right? That's just subtract the two functions and then divide by another function. Hey, great. So now here we kind of want to know where this came from, perhaps, because we're curious. And so the idea is that we look at the average rate of change, right? And we say, okay, well, that we know is the slope of the secant line, and we know how to calculate that given 2 points on a function. Okay, so now the only thing that changes is that this x2 is now, we say it's x plus h. So it's saying if the first one was just x, we kind of step away from that positively or negatively a little teeny tiny bit. That's the h part. Okay, and then, okay, if we move x a little bit, then we got to figure out what y is. And so then that's, if you go through the math with that substitution, hey, great, you get that expression in red. Okay, now, history aside and fun stuff aside, difference quotient. All we have to do to figure out what this red thing is do 3 steps. Find f of x plus h, find the difference, and then divide the difference by h. Okay, here we go. I'm going to do one, you're going to do one. Difference quotient for this. Okay, I'm going to do each step in a different color. So I'm going to do f of x plus h first. Okay, if I do that, that says, okay, every occurrence of x gets replaced with x plus h. So I do x plus h squared minus 3, and then x plus h. Okay, and then I expand it out and simplify if I can, which I'm not going to be able to. Okay, minus 3x minus 3h. Okay, boom, step 1 done. Step 2, find the difference of f of x plus h and f of x. Okay, now this step, honestly, it's the longest to write out, but it actually reduces quite nicely. Okay, x squared minus 2xh, or plus 2xh. I'm just copying the thing I found in kind of from step 1. Oops, I don't want that parentheses there. Minus 3x minus 3h, and then subtract now f of x, which is x squared minus 3x. Okay, now you can distribute the negative to both of these, or the negative one, whatever. Big idea, x squares cancel, 3x cancels out. So what I'm left with after everything cancels out is 2xh plus h squared minus 3h. Huh, that's not too bad. Last step, take that difference that we just found and divide it by h. So that is to say, okay, we have 2xh plus h squared minus 3h all over h. Now, so there's some people that do this incorrectly when they say cancel. Oh, we cancel those and we're done. Not exactly, right? Sometimes it's most useful to say, okay, well, you can cancel an h from each term because we have 3 terms in the numerator, each of which needs to be divided by h. Another thing that people sometimes do is factor out an h. There is an h in common with everything in the numerator, and then that makes cancellation a little bit more easy, and so I'm left with 2xh minus h minus 3. Plus h. There we go. So, there we go, and that would be all we have to do here. And I made another error. That should not have an h. There we go. So, we found the difference quotient. Yay! Okay, moving on to something a little bit more somber. We want to find the difference quotient for this thing. Now, I'm going to have you do this on your own and check the video for the solution later on. I will say you need to find common denominators here. It does get to be a tidbit ugly, but bear with it. It all works out quite nicely in the end. Alright, and here's the solution. Now, just a few comments. Step 1 isn't too bad. Step 2, we're pretty good until about this step, and that's when students start to kind of get lost and like, oh, where'd the negative come from? Well, remember, this negative has to be distributed. Okay, so remember to distribute the negative. Now, the third part here is perhaps where students get the most confused and get lost in their work, and it's because you have a fraction within a fraction. And so my strategy that I always do, so this is kind of what the definition of the difference quotient says, but then remember that every thing always has a denominator of 1. So then when you include that denominator of 1, particularly when you have a fraction within a fraction, you're like, oh, I have a fraction, and then we have divided by a fraction. So then, oh, I know how to do that. That's just the fraction multiplied by its reciprocal, and boom, you're done. Okay? So just remember, take a little bit of time and think about the mathematics that you're doing, and double check all your work.